All right, ready to dive into some fascinating neuroscience. Today, we're talking about how our brains predict sensations.
Predicting sensations. I like the sound of that already.
I knew you would. So
Yeah.
you sent us this research paper on the phantom touch illusion, and, well, the title alone got me intrigued.
It's a pretty catchy title, right? And the research itself is even more captivating.
It sounds like we're going to explore how our brains can create sensations even when there's no physical touch involved.
Exactly.
Okay, so let's start with the basics then. What exactly were the researchers trying to understand with this study?
Well, they were really interested in the concept of tactile gating and how it plays a role in our sense of touch.
Tactile gating. You could break that down for me a bit.
Sure, think of tactile gating like a filter in your brain.
A filter, okay.
And this filter helps you distinguish between touch sensations that come from yourself, like when you touch your own arm, versus those coming from something external, like someone else tapping you on the shoulder.
Ah, I see. So it's how our brain knows the difference between self-touch and being touched by something else.
Exactly. And here's the thing. When you touch yourself, your brain actually predicts the sensation you're about to experience.
It predicts a sensation.
Yep. And that prediction basically cancels out the actual sensation itself, which is why, you can't tickle yourself.
That's right. You can't tickle yourself. So the researchers wanted to see what would happen if they messed with that prediction a little.
Exactly. They wanted to create a situation where the brain's prediction was there, but the actual touch wasn't.
So they were basically trying to trick the brain.
You could say that.
That's so cool. All right, I'm all ears. How did they set up this experiment?
They used virtual reality.
Oh, well, VR.
Yeah.
Hmm.
Participants put on VR headsets that showed them a virtual representation of their own hands, but they couldn't actually see their real arms or forearms.
Interesting. So just their hands floating in the VR space.
Right. And then they were given these virtual sticks, and they could use the sticks to stroke their virtual hands.
So they're seeing their virtual hand, and they're stroking it with a virtual stick. But there's no actual physical touch happening.
Exactly.
Okay, my mind is already starting to bend here. What happened next? Did they feel anything?
You're going to love this. They did.
Really? Wow.
They reported feeling a touch sensation right where that virtual stick was stroking their virtual hand.
No way. So they were feeling touch, even though nothing was physically touching them.
That's the phantom touch illusion in action.
That's incredible. What did that phantom touch feel like?
Most of them described it as kind of a tingling sensation. Some said it felt like static electricity, and a few even said it was like wind passing through their hand.
Wow, that's fascinating. So it sounds like it wasn't like a super defined sensation, but more this general feeling in the area they were virtually touching.
Exactly. Yeah.
Did everyone feel this phantom touch?
Almost everyone. Out of all the participants, only 4 didn't feel anything.
Wow, so it seems like a pretty consistent phenomenon.
It really is. And here's where things get even more interesting. They found that the illusion also worked on parts of the virtual hand and arm that the participants couldn't even see.
Wait a minute. They couldn't even see the part they were stroking.
Nope. Remember, they could only see their virtual hands in the VR setup, not their forearms.
Right.
So the researchers had them try stroking their virtual forearms.
Hold on. And they still felt it, even though they couldn't see it.
Yep. They still experienced that phantom touch sensation on their forearms, even though those were completely invisible to them in the VR environment.
Whoa, that's wild. So it's not just that they're seeing something and their brain is making them think they feel it. There's something deeper going on here.
You got it. It's not just a simple visual trick. It seems like our brain has this internal map of our body.
An internal map.
Yeah, a sort of body schema that influences how we perceive touch. And it's playing a role in this phantom touch illusion.
Okay, this is seriously blowing my mind.
Yeah?
It's like our brains are creating touch sensations based on where it thinks our body parts are, even if we can't see them.
Exactly.
Wow, this is absolutely incredible. All right, I need a moment to process all of this. So far, we've learned that researchers created a clever VR experiment to explore how our brains predict touch. And they discovered that people can actually feel a phantom touch when nothing is physically touching them.
And what's even wilder, that illusion isn't limited to what they could see in the VR. They felt it even on their invisible forearms.
Like our brains have this internal map, this body schema that's helping create this illusion.
It really is amazing, isn't it?
So what else did the researchers find out about this phantom touch? I'm hooked.
Well, one of the first things that comes to mind is, could this just be a result of the participants being in virtual reality?
Right, or like maybe even a placebo effect.
Yeah.
just because they're expecting something to happen.
Exactly. And to their credit, the researchers actually thought about that too. They designed a whole control experiment to try and rule out those possibilities.
Oh, interesting. What did they do in the control experiment?
Okay, so instead of having the participants use that virtual stick to stroke their hand, they had them use a laser pointer.
The laser pointer. Okay.
And they had two conditions. One where the laser was on, so the participants could actually see the red dot moving across their hand, and another where the laser was off.
Oh, clever. So they were isolating just the visual part of it, seeing if just watching something move across their skin, even without any tactile stimulation, would be enough to trigger that phantom touch.
Exactly. It was a way to separate out the visual component from any actual touch sensation.
Okay, so what happened? Did they still feel the phantom touch with the laser pointer?
So the results were different. Some people did report some sensations with the laser pointer, especially when it was on.
Okay, so some people did feel something.
But here's the thing. The sensations they reported were much less frequent and less intense than when they were using the virtual stick.
So it's not just that they're seeing something and their brain is automatically thinking it's touch. It really seems to be tied to that prediction of touch in the context of interacting with that virtual representation of their own body.
You've got it. The control experiment really helps to show that the phantom touch isn't just a placebo effect or some side effect of being in VR. It's something specific linked to the brain's own internal model of the body.
This is so fascinating. It really makes you wonder, if our brains can create touch sensations without any physical contact, what does that tell us about how our brains construct our reality?
That's a deep question, and I think this research shows that our brains are always making predictions about what we should be feeling based on our experiences and what's going on around us.
So it's not just our senses directly feeding information to the brain, it's also the brain's own predictions filling in the gaps.
Exactly. And when those predictions don't match up with the actual sensory information coming in, our brain tries to make sense of the discrepancy.
So like in this phantom touch illusion, the brain is predicting a touch sensation because it sees that virtual hand being stroked, but there's no corresponding tactile input. So the brain just kind of fills in the gap and creates the sensation, even though there's no physical touch actually happening.
Exactly. And this study highlights just how powerful those predictions can be. It challenges the idea that our perception of the world is just this passive receiving of information from our senses. Our brains are actively involved in shaping our experiences.
This is really making me rethink how I understand my own senses. Okay, let's shift gears a bit and talk about the researchers behind this incredible work. Who are the minds that brought us these findings?
Well, the lead author of this study is Artur Pilacinski. He's a neuroscientist at Ruhr University Bochum in Germany.
Okay, so a German neuroscientist.
Yep. And his research focuses on touch perception and how the brain creates a representation of the body.
So he's really a leader in this field.
Absolutely. His work is pushing the boundaries of our understanding of how the brain processes sensory information.
And who else was involved in this research?
Well, the study was co-authored by Marita Metzler and Christian Klaes.
Okay, Metzler and Klaes.
They're also from Ruhr University Bochum. So it was a real team effort.
A team of German neuroscientists exploring the mysteries of the brain. I love it. This has been an absolutely incredible deep dive so far. We've learned about the study's goal, the clever way they set up the experiment, those incredible results, and we even got to meet the brilliant minds behind it all. Now, before we wrap up, I want to leave our listeners with something to think about. If our brains can create phantom touch sensations like this in virtual reality, what other kinds of sensory experiences might we be able to create or manipulate using technology?
It's a fascinating question to consider. I mean, think about it. Could we one day have virtual reality experiences where we could actually feel textures, temperatures, maybe even pain, and all without any physical contact?
That would be incredible. Like feeling the weight of a virtual object or the roughness of a surface, or even the warmth of a virtual handshake.
It would completely change how we experience virtual reality. Gaming would be so different, training simulations would be more realistic, and even just collaborating with people remotely could feel much more real. And it's not just about entertainment and technology.
Yeah, this could have huge implications for medicine too, right?
Absolutely. Think about people who've lost limbs. Could we use VR and this knowledge about tactile gating to help them experience a sense of touch again? Or maybe even alleviate chronic pain conditions?
That's incredible to think about. It's like something out of science fiction. This whole phantom touch illusion really shows us how much we still have to learn about the brain It's amazing how it can shape our reality, even creating sensations that aren't really there.
I completely agree. It really opens up a whole new world of questions about how we perceive the world, the role our senses play, and the potential for technology to change our sensory experiences.
It's mind-blowing and maybe even a little unsettling. But mostly it's just super exciting. It makes me appreciate even more the incredible power of the human brain.
It truly is amazing.
Well, I think we've given our listeners a lot to think about today. It was fantastic exploring this research with you. Thanks so much.
It was my pleasure.
And to you, dear listeners, keep those brain cells buzzing, and we'll catch you on the next deep dive.